Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Everyone, hey, I hope you're having a wonderful Friday and you are ready for some Computer America. Today on the show we have, of course, Ralph Bond. He was kind enough to work around our schedule, and yeah, he's here a little bit later than usual, but he is here nonetheless. So looking forward to a ton of stories. If for those who don't know, he is our science and tech trends correspondent. So yeah, these are stories that may not have come across your radar. I know that browsing through them before the show here, we have not talked about a lot of these. So this is all going to be good news and hey, new news as well. Everyone, so sit back, relax. ComputerAmerica.com. That's all you have to remember. We're going to have the show notes up right after the program, and of course you can find them on Ralph's website, which will also be linked in the show notes. Yeah, and ComputerAmerica.com. That's all you have to remember. Of course, if you want to watch the video portion, that's up on our website or twitch.tv/Computer America as well, and that's going to be good for videos and other more the visual aspect of the program, although we are primarily a radio show. So if you're listening to us on IRN, we appreciate that a lot, or of course the podcast as well. Now, that's my way of saying my whole spiel long, and why don't we go ahead and just jump right into today's program with, as I said before, Ralph Bond. And I actually need to, I forgot one little detail, but it should be okay. Ralph, welcome back onto Computer America. And for everyone out there, he has of course been the voice of Intel Digital Minute, times gone here on Computer America, and of course has helped us with a number of aspects with the show. And hey, all around, he's a really great guy. So Ralph, welcome back on to Computer America. How you doing?
Hey, it's great to be back, and I hope wherever you are, folks, you're not roasting to death in this terrible heat wave that's hitting so much of our country. Even here in Oregon, we're looking forward to a Monday where it could be 100 degrees, and for us, that's just unthinkable, especially this time of year. So God help us all with climate change.
And it's crazy that, climate change seems like something that for the past 10 years we've been thinking, this is, it's starting to happen. It's going to happen soon. It's going to get worse. And it seems like this year, especially, and of course, I'm sure people in California and Texas with fires and droughts of their own, they've, been feeling this for a while. But it seems like this year, it's really like, oh, it's here. It's climate change is here. It's crazy.
Yeah. Yeah. Well, and a bright note is you may have heard that GM and Ford, I hope I have this right, recently announced that they both are going to fully commit to electronic vehicles. I think within a few years, they're going to stop producing combustion engine vehicles. Did I hear that right? Did you hear that story too, Ben?
Yeah, they were going to,
major
and
announcement.
hey, I was just autoplay videos, they're the best. Yeah, and just pull up this article here. This was just like a couple days ago. GM and Ford outdo each other with electric vehicle investments, and essentially both of them are, looking at 2025, 2020, or 2030, and yeah, they're both trying to, Ralph, and really, it's just building enough batteries because imagine every every engine that's being built right now, you have to have a comparable amount of batteries. And so, just like Tesla did, everyone is starting up a battery production facility. So electric cars are going to be here even faster than we thought. So that is good news. Yeah.
And one little side note, by the way, before we jump into the first story is my wife and I just bought a plug-in hybrid. It happens to be a Toyota RAV4 Prime, which is a plug-in hybrid. And folks, if you're in the market for a car, and I'm not endorsing Toyota over anyone else necessarily, but consider a plug-in hybrid. Why? You can go all electric for X number of miles, in our case about 40, 45 miles, pure electric. Then it switches into traditional hybrid mode. So it's sort of like the best of both worlds. We never have to worry about range, but yet at most, like 99% of our driving is all electric. So think about that if you're on the market.
Yeah, those those options are going to be very standard. And one more little renewable energy fact that I don't think I shared on the show before, but I think it's like all engines produced by Rolls-Royce for like airlines and airplanes and stuff like that are going to be running on renewable fuel by 2023. Nice. So
good.
Stuff's happening. It's just a question of, did we give ourselves enough breathing room? Because it seemed like you said, doesn't seem like it, especially in those really hot places.
Oh, boy.
So, but let's go ahead and switch over to something a little bit different. And we can go ahead and start with the show notes, which again, after the program airs live here, we'll have that available on our website and of course on Ralph's website as well with full show notes. So you can check that out there. So don't worry about links or remembering anything like that. You just have to listen to myself and Ralph, and it's going to be fun.
There you go.
Ralph, story number 1.
Yeah, story number 1, headline: Brain implants turn imagined handwriting into text on screen. Okay. ScienceNews.com is a source story by Anshari Dave. I hope I'm saying that name correctly. And let's get into this. A team of researchers at the Howard Hughes Medical Institute at Stanford University reported in the May 12 edition of the journal Nature that electrodes placed in a paralyzed man's brain turned his imagined handwriting into words displayed on a computer monitor screen. Let that sink in for a second. The potential benefits of this for people who are tragically paralyzed, can't even speak, are profound. So a 65-year-old man had 2 grids of tiny electrodes implanted on the surface of his brain, and the electrodes read electrical activity in the part of the brain that controls hand and finger movements. And although the man was paralyzed from the neck down, he imagined writing letters with his hand. Wow. Using a remarkable algorithm, the researchers then figured out the neural brain patterns that went with each imagined letter and transformed those patterns into text on a computer screen. And from his brain activity alone, the participant produced 15 words per minute. And that might it's not bad. It may not sound like a lot, but it's not bad because that's about the average typing rate. Typing is a misnomer here a little bit, but thumb typing, if you want to call it that, on smartphones for people around that person's age. Again, he's 65. The translation from brain to text may ultimately point to ways to help people with disabilities like paralysis communicate using only their thoughts. Wow. Super wow. I mean, to me, this was one of the most important medical technology breakthrough stories in the past, say, year, I think.
Yeah, and I'm actually curious because I think when people think about paralyzed people typing, one of the first people that they think about is of course Stephen Hawking. He famously did not upgrade the voice of his speech to text, or I'm sorry, text to speech. Right, but I think he did work very hard to get improvements in kind of getting his typing out. I'm kind of curious how fast he was able to kind of do things and translate things like that. one of the things to point out here, which I was just reading that on Nature, I guess, Ralph, there's a difference between like what's traditionally been done, because they mentioned like, they move their eyes or they think about a particular letter, they move things. It's very kind of, A to B. I guess, thinking about handwriting, and I don't know how many people out there actually handwrite on a day-to-day basis anymore, but there's a lot of fine motor skills, going along with that. It's a lot of little translations instead of just big thinking about the letter A.
Excellent point. Yeah, you're right.
It's a huge improvement, and it's actually much more difficult than you would think. It's not just writing; it's every little movement that they're able to do. So,
you raise a good point, Ben, because if you think about again, if you imagine, I'm going to imagine I'm writing a lowercase a, okay, and so what they must be doing is tracking each the brain response for each part of the arc of the lowercase a, and then the tail. Right?
Yeah.
Wow. I mean, you're right. I mean, that is so much more in depth than tracking my eye movements, where I might have a keyboard screen on display and my eye goes to A and then B and whatever. Yeah, you make a very good point. Very sophisticated.
Very sophisticated. And the fact that they're able to get 15 words per minute, I'm sure that as he works with it and as they work with it, it'll get better and better. But
yes,
I can imagine one of the nice points about that, Ralph, is also that, each letter is fairly distinct. Obviously A, D, B, whatever is going to be, pretty close. But it's great accuracy, great speed, and great advancement. And again, something that we had not covered on the show before. So perfect.
Yeah, fun story.
Perfect story. Story number 2. Let's go ahead and talk about this one as well.
This one. And when I first saw the headlines of this, I thought, is it kind of a joke, or is this a fake story? But no, it's the real deal. So here's the headline. University of Central Florida and DARPA researchers demonstrate, get this, sarcasm detector for online social media, and text messaging communications. And I got this story from a variety of publications, but I went right to the DARPA press release, which I thought was the most interesting source. And here's the setup. So, of course, for businesses, understanding the sentiment of online social media text communications can help process customer feedback and gather insights to improve marketing efforts. Okay, that's for business. But for military defense perspective, sentiment can be an important signal to help online information operations identify topics of concern or possible actions of bad actors. But again, how do you know whether a text message is really something scary or just sarcastic?
Right.
Help quickly evaluate large, let's say huge volumes of social media text messages. Researchers from the University of Central Florida worked with DARPA to develop an artificial intelligence-enabled sarcasm detector. I love this. And just to refresh for some folks that may not recall, the DARPA stands for Defense Advanced Research Projects Agency. Okay, the sarcasm detector works by identifying words from tweets and other online text messages that exhibit crucial cues for sarcasm, including sarcastic connotations or negative emotions. And then the artificial intelligence-based model then tracks dependencies between the crucial cue words and generates a classification score indicating whether or not sarcasm is present. So I kept thinking, wouldn't this be great to have if you have teenage children and you could, detect whether they're being sarcastic or there's something scary going on here? I digress, but it's a very curious technology challenge.
Well, one would hope that, any person that's doing this would be able to detect sarcasm, or, you would hope. Obviously, it's very difficult over text for even people to do. But, Ralph, think about all the different, AI chatbots and things like that have been pulled offline and, just kind of ended because they started going off the rails. They were, becoming racist, and they were just, doing because they take everything literally. And, that's just, I'm sure, one of many problems that chatbots have. But being able to do that, I know that we covered the story a while ago, but it was IBM being able to have like the phone tree and like automated phone systems detect a level of, someone's emotional state. So they could tell if someone over the phone was getting frustrated, if they were getting angry, if they were getting, that whole thing. Emotions through voice is one part of it, and then of course emotion through text is the other part of it, and this could lead to, like you were mentioning, much more accurate, I guess, kind of early alert systems if something is going wrong, or if it's really not going wrong at all. So,
and the way I look at this, Ben, is it's sort of saying, okay, I'm sure DARPA and crew and our military and all of our government watchers, if you will, have all kinds of technology to look for, as you pointed out, trigger words, racism words, hate words, violent words. That's kind of sort of easy in a way because you just look for specific words. But to take it to this next level of nuance, right? Is it sarcastic, or is it serious, or what, right? And that's the thing that I thought was so interesting about this particular story.
Right, and I definitely like this, this large amount of text, social media tweets, things like that. But also from the press release, the team leveraged publicly available data sets, as you mentioned, including Sarcasm Corpus V2 Dialogues dataset, blah blah blah, but as well as news headlines data sets from The Onion and HuffPost. So essentially, I know that The Onion in particular is very, very sarcastic. Like it's hard to get more sarcastic than The Onion. And it's kind of fun that they used a satirical newspaper to, I guess, kind of train sarcasm. Makes perfect sense though.
Yep.
Very, very fun. So yeah, and hey, I hope that it definitely gets better. And of course this means that moderation, automation should get better as well. So Facebook, social media, all would improve from that. Story number 3, and we go from DARPA to the Army.
Yes. And before we even jump into this story, I'll tell you that this story raised more questions for me than I could find answers for. This story was covered by a plethora of publications, including Popular Mechanics. I happened to start off with Tech X Explore, but then I also went to the Army Research Laboratory's web resources, and I've got the links and the video and all this good stuff in here. But here's the headline, folks. Army strengthens future tech with muscle-bound robots. Ding, 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 I'll be back. I mean, the first thing I thought about is, here we go. We're on our way to having a Terminator.
Well, and of course, the first thing I think of is, like, I thought muscles were kind of a bad thing because robots don't have muscles. They don't get hurt, but I guess they're a good thing in some applications.
And you're kind of drifting in the territory where my mind was going too. So here's the story. In new research from a team of scientists with the Combat Capabilities Development Command Army Research Laboratory, say that 5 times in a row, living muscle tissue, muscle tissue, that starts raising all kinds of questions in my mind, will be added to Army mechanical systems like 4-legged dog-like robots. Okay. The Army Research Laboratory is teaming up with collaborators at Duke University and the University of North Carolina on studies in what is called biohybrid robotics. That's the part that makes me think of Skynet and the Terminator, right? Researchers envision a future where 4-legged robots have muscle tissue added to or used for robotic joints in place of traditional electronic actuators. All right. Well, muscle at its core can accommodate unpredictable needs because it stretches. Okay, we all get that. Embedding muscle tissue in future robots is expected to produce never seen before agility and versatility. Okay, fine. This, in turn, they hope will open new opportunities for robots to venture into spaces highly risky for warfighters. Now, their research is expected to inform the biohybrid engineering community on how to culture strong muscle tissue. Now, note, cultured tissue may consist of a single cell, a population of cells, or a whole part of an organ. Cells in culture may multiply, change size, form, or function, exhibit specialized activity. Muscle cells, for example, may contract or interact with other cells. All right, all this is fascinating, spooky, weird, you name it. And I said, well, wait a minute. Living muscle tissue, Ben, of course, living muscle tissue, and I did a little more medical research, if you want to call it that, has to have basically two things: a blood system to provide oxygen for the muscle, and a nerve system, as it were, to actuate the muscle. Now, you can actuate a muscle with a little electric shock. Of course, we all know that, make it twitch. But my big open-ended question is, okay, this is fascinating, but how in a mobile robot, battery-powered robot, are you going to sustain living muscle tissue? So that's the part that just kind of made me go, is this for real? And I kept digging and looking at all the resources, and none of the resources I saw gave not give a direct explanation for what I'm referring to. I don't know what your thoughts are, Ben, on this, but it's pretty weird stuff.
And it's kind of funny. This field of research is something that I've followed kind of closely because I like meat, and I also like. I would like it if my meat came from sources that didn't have to kill animals. So being able to grow muscle tissue, this is the actually something that you have followed as well, which is culturing organs. Essentially 3D printing organs. Yeah. Exactly, bioreactors, and that's one of the main reasons why you can't currently have a T-bone that was built in a bioreactor is because then you just have a big mass of muscle. They're not connected to each other. They're not they weren't connected to each other. They weren't stressed, and they you essentially can't print a steak because all the cells are next to each other, and they may be identical cells, but they're not formed together like a living organ would be. And then the other part of that was the cell structure, Ralph. That's why a particular, and I draw attention to a story that may be kind of gross, but there was a doctor, Ralph, that used to I really hope he has lost his license to practice by now. He was doing trachea replacements for people who had throat cancer or things like that, and he was pushing the technology before it was finished. He was 3D printing people's own cultured cells, kind of throat muscle cells onto a plastic tubing. And he never really got the hang of, printing in a working vascular system. So, unfortunately, these people had this trachea replacement, and all the tissue died in their throat because there was no, there was no blood flow. There was no way to get nutrients to the muscle. And of course that led to a lot of complications and a lot of pain. So obviously, like you said, we don't have this perfected for humans. How are we going to do it for robots? The only thing I can say is that obviously robots are going to have battery powers and battery power systems. And Ralph, we already have pacemakers. We already have ways of, pumping blood and delivering energy to a system. I guess if it had like its own glucose reserves and you can actually get that to it, I mean, that'd be great.
And oxygen, I can't say it today.
Yeah.
Get oxygen in it.
And oxygenated blood and all that kind of thing. Like you would have, a lot would have to go into this. And I'm glad that they're looking into it because there's a lot of applications beyond robots and, kind of what they're working with. But it is yet another use, I guess. And I guess what they're saying there is like, obviously with robots, with actuators and all the parts, very mechanical. They only have a certain amount of movement, flexibility. As soon as you add the muscles in, it can do so much more. It can be much more lifelike. They're so far from actually accomplishing what this article is kind of saying, Ralph, that I'm with you. How are they going to do it? And you could do all the digging you want. I'm sure that the real answer is, well, this is step 1 of step 50 or 100. I mean,
Yeah. I think it's more, my takeaway in a way is we're looking at this. We think there's a possibility. Stand by.
Exactly. But, And again, the videos are very intriguing as well.
Yes.
It's always fun to see something that looks a little bit like Boston Dynamics, but
a lot like Boston Dynamics.
Yeah.
Yes, exactly.
But of course, taking it another step further. So there you go. Story number 3, story number 4, and IBM.
Yes. Good old IBM here. An IBM survey finds that 1/3 of business organizations are using artificial intelligence in a way that's kind of not surprising. Comes from VentureBeat, a story by Kyle Wiggers. Mm-hmm. That's Wiggers with a W, folks.
Yes.
Okay. IBM's recently released Global AI Adoption Index study found that 1/3 of companies surveyed are now using artificial intelligence and are planning significant investments in AI throughout the coming year and beyond. Adoption, they said in the study, is being driven by both pressures, business pressures, and opportunities, from the pandemic to technological advances that make artificial intelligence more accessible. Of the categories of artificial intelligence businesses are adopting, natural language processing is at the forefront. Natural language processing, of course, is all about giving computers the ability to understand text and spoken words. Almost half of the businesses surveyed said they are now using apps powered by AI-enabled natural language processing, and 52% of companies reported deploying or considering the deployment of natural language processing for customer service. Now, that's all well and good, but my complaint is, how many times have you and I and our listeners, you've been on a chat or an exchange and you think you're talking to a human being and you just know it's not happening, right?
Yeah.
And so it's all well and good for them to invest in this natural language, but I don't think it should be in lieu of a human being if you really need to talk to a tech support person, a human being. So that's my soapbox on that one.
Well, we both see the writing on the wall that eventually, Ralph, yes, this will replace 100% of people in a tech support role, wherever possible. But at the moment, they will probably function, kind of in conjunction with one another, and make sure that, if you're having an accounting issue, it gets to the bottom of it and sends you to an accounting person. If you're having a tech issue, get there, that whole thing. Ralph, the bigger concern, and this is something that I think one of your other stories here, and it was actually the high performance. I think it was the brain one, which also uses AI, and of course this DARPA. Really, almost all your stories so far have been AI related. So that seems to be the flavor of the day. But the bigger concern, Ralph, that I think a lot of people in the world are kind of concerned about when it comes to AI is that AI is not really understood. I mean, only one article here has kind of mentioned this idea that there should be a non-black box kind of way that these things are built. Because right now, you have experts in the field collect as much data, as much useful data, as much clean, organized, and processable data, send it through an algorithm, and eventually you train it, and really what pops out the other end, you hope is the result you're looking for. If you train it to look at pictures of cancer, hopefully it can identify pictures of cancer. My point with that is that middle part, Ralph, that those are right now kept as kind of trade secrets. Every company pays incredible amounts of money. How it actually works, how it, you can't exactly look at the source code, how it actually works. Those are all secret. Every company, I'm sure IBM, is doing this as well, has their own AI that no one knows how it works. They're not sharing the information with each other.
Right.
There's no standard, we're all driving the same roads, but no one's going to have the same AI, working with each other. So that might be an issue in the future where someone is going to have a clearly better AI. And what do you do when there's no competing with someone's better AI? And for businesses, they all hope to be that one, but eventually someone's just going to win out. So
those are very interesting points. As you were speaking, I was thinking about some fantasy of very what would be the word? A very kind, very positive, formatted, open source AI consortium of some kind.
And that's already happening, where they're saying that AI is just so transformative of a technology. We can't afford to let one company, one person, one country, one organization have the best. Yeah. So, and not only that, Ralph, but, think about how much faster AI would evolve if everyone shared what it is they were working on. So yes, there's already consortiums out there looking to ethically and kind of jointly produce these AIs, but still a lot of work to be done there as well. But Ralph, again, if anything, your story has shown, from helping the paralyzed to, climbing over obstacles with robots to,
Sarcasm.
of course, sarcasm detection to, of course, just general investments in AI, it's going to affect almost every part of our lives. And, how do we culture that? How do we make sure that doesn't get out of hand? So.
Oh boy, yeah, it's a very interesting. You think climate change is a daunting challenge? AI is.
AI is right up there. Yeah,
and AI has so much potential for good.
Yeah, absolutely.
But also evil.
It almost seems like, as well as like to me, and I did not exist back then, but it seems almost on the level of like nuclear proliferation, where you have this amazing technology, and how do you obviously it's not going anywhere, but how do you kind of keep it in check? And that's going to be something to answer in the next 10 years. So
you could write a book called The Pandora's Box of AI.
I'm sure there's already been 1,000 books like that. And again, like you said, Terminator would be also a good study case. But there you go. So in Terminator, I mean more like Skynet, obviously. But story number 5. Let's go ahead and move on to something a little bit different.
Yes, more simple and much more easy to wrap your arms around.
Look, a boat.
And so here's the headline: a new all-electric seaplane glides above the water like a hovercraft. This comes from the ROB, that's ROBB report, story by Daniel Bachman. And you really need to get the show notes, or if you're online right now following us, you're able to see the photos, or the images rather, of this really remarkably attractive, I think, cool looking boat plane, if you will. So there's an all new electric water taxi aircraft that takes off and lands on water the same way a float plane does, but flies at 180 miles per hour just above the water's surface. So this thing's fast. Designed by 2 MIT aerospace engineers, the new Regent, that's the company they've created, that's REGENT, Sea Glider will serve as a very fast commuter taxi between urban centers and coastal areas. The team at Regent says their all-electric 8-engine Sea Glider will offer a 180-mile range before needing to be recharged, and it will travel 6 times faster than a conventional water taxi. As the Sea Glider lands on the water, it switches to using hydrofoils attached to the hull of the craft as it taxis to the dock, and that's so well shown in the video and the pictures. According to the company's website, the innovative design offers an edge over other electric and conventional seaplanes, as it doesn't need any special infrastructure. That means it can use existing docks. And the Regent team claims their Sea Glider can be operated at half the cost of traditional seaplanes, and with much less noise and, of course, zero emissions. To date, Regent has received $465 million in provisional orders from commercial airlines and ferry companies. So just kind of a fun, all-electric, in this case, aviation breakthrough that I think is kind of neat.
I'm going to send them a message as we speak. And although, seeing it, seeing what it does, Ralph, have you ever seen people who kind of already do this? Like with, it's called hydrofoil.
The hydrofoil is right.
Yeah. And of course, you can do it with surfboards and wakeboards and things like that. And it seems like this plane,
inflated rafty type hydrofoil guys, and the boats.
Kind of. Oh, and hydrofoil is just having that, kind of that secondary little, I won't say like rudder, but it's not really a rudder, that goes underneath the waves. And then you, of course, float, a couple of feet off the water. That whole process, it seems like they're just taking that and doing it with a plane that can kind of pull itself along using the air. Really simple, and that's what I love is that we don't have to wait for the Jetson technology. We don't have to wait for something to happen. This has been in use for the last 30 years. Like this technology is known. Making it into a plane, though, that's a new one. And of course, making it carry passengers, that's really cool.
Yeah, very cool. And it's good looking too.
It really is. And of course, let's see, there's a couple, I'm going to probably include this. I can just show people if you're watching the video portion. I mean, this is just hydrofoiling in Hawaii. So like essentially that technology, but in a plane.
Oh, yeah.
Very, very cool. So I like that one a lot. And again, I'm going to contact them right now to see if they want to come on the show. That's
good. You should. I'm sure those guys would be fun to talk to.
Absolutely. So story number 6, and hey, another advancement for people who need help. The blind.
I have such a soft spot for technology helping in the medical world, and certainly helping anybody with disabilities. Believe me, as you know, that's one of the things I care about a lot. So, headline: scientists partially restore. Now that's a qualifier. Partially restore blind man's vision with breakthrough gene therapy. So the potential of this story is what you need to think about, not the literal stage we're at right now. Pick this up from CBS News, but it was covered by many, many outlets. Story by Sophie Lewis. We've got a link, of course, a picture of the person in question. And for the first time, scientists have partially restored the vision of a blind man. According to a study authored by a scientist from the University of Basel in Switzerland and published in the journal Nature Medicine, the blind man was treated with optogenetics therapy, which used, and this is the part, just let this sink in, was treated with optogenetics therapy, which used algae proteins to control cells in the eyes. Algae proteins. I was hooked. I had to know more. 40 years ago, the man was diagnosed with retinitis pigmentosa, which is a rare genetic disorder that breaks down fragile photoreceptors or light-sensing cells in the retina. Optogenetics is traditionally used by neuroscientists and involves manipulating cells to make them sensitive to light. In this case, scientists used optogenetics to partially restore the man's ability to detect light in one of his eyes. So let's kind of, put this into perspective, no pun intended.
Well, they probably didn't want to just, go at him with both eyes, just for safety reasons. Yeah.
Well, that's a fair point. The technique used involved algae proteins that respond to light sources with movement. Okay, this is geeky, but here's what they did. Scientists took the algae protein genes and injected them into the remaining functioning ganglion cells in the retina to make them produce the light-sensitive protein crimson R. Now, I'm not an expert in this field. To me, it's a lot of gobbledygook. But once formed, the crimson R proteins could then respond to light and send image signals to the man's brain. So this is a beginning. It's a breakthrough. God willing, this is going to progress, and we might be able to help people who are totally blind restore more of their sight and better. Maybe someday, who knows, in the future, full vision.
Right. And from what I remember when, this happened a couple of weeks ago and, kind of reading the comments about it and seeing about it, this is treating one particular type of blindness that affects, as the article said, 1 in 4,000 people. So this is not, tragic accident, lost sight, that kind of thing. This was a genetic defect that,
good point.
Yeah. So, but still, the fact that they're working on, not just one type of blindness, but working on many types of blindness, that doesn't mean that there's not hope for everyone else. But hey, it means the research is going in a lot of different ways at once. And like you said, algae protein to reactivate those cones and, and reactivate
at least
cells.
It's not a rare mineral.
At least that's really incredible. So Very cool, and like you said, it's and actually I was watching the video. We had it up there when you were doing the article. One of the reasons why they may have only done one eye, Ralph, was that they could monitor. They could cover the treated eye and see what the results were without treatment, and then cover the untreated eye, and kind of get a nice side by side comparison on how effective was the treatment. So that could also be why they just did one. But
very cool.
Yeah, very, very cool. So there you go. Story number 6. Still plenty of time. So we can go ahead and move on to story number. Yeah, and by the way, this one was actually one that we did do on the show, but it's worth reiterating because artificial intelligence. Yeah, let's go ahead.
It's fun. So for everyone who listens to the show every day, this might be a little bit of a repeat, but I just thought I fell in love with this story, and I love the videos of this. So headline: Artificial intelligence makes Robert De Niro perform lines in flawless German. And this one I got from Wired, a story by Will Knight, and it was covered, as you point out, in many, many outlets. And absolutely encourage you to see the videos and to hear and watch and see how this works. It's really just something else. There's a video embedded in the article that's great. And then there's another video I have in the show notes. So here we go. A new artificial intelligence-based deep fake technology can now allow Robert De Niro to deliver his famous line from Taxi Driver, "You talking to me?" in flawless German and other languages, with realistic lip movements and facial expressions. That's the key. The AI dubbing technology was developed by an outfit called Flawless, a company co-founded by British film director Scott Mann, who says he became tired of seeing poor foreign language dubbing in his films. The new artificial intelligence software manipulates an actor's lips and facial expressions to make them convincingly match the speech of someone speaking the same lines in a different language. Stop and think about how amazing that is. The technology is related to deep faking, which, for example, can use AI software to paste one person's face onto a photo or a video of someone else. We're familiar with that. This new technology promises to allow filmmakers to effectively reproduce movies in different languages and at the same time remain more faithful to the original. So I just thought it was a hoot. Plus, I'm a De Niro fan. The guy's great.
and I'm assuming that I won't get in trouble for doing this, but yeah, that the video shows kind of traditional dubbing and just for educational purposes. Let's see, I think I can unmute this. And
good. Tom Hanks.
Yeah. So
Wo sind Sie? Herr Boss. Mit einigen der bekanntesten und kriminellsten Familien in dieser Stadt in Verbindung bringt und du lässt sie in einen Busch.
So for those who were only listening to that, obviously it sounds like German, and that kind of thing, and it sounds a little bit like De Niro. But if you're watching it, it looked like Robert De Niro was speaking German. And of course they have You Can't Handle the Truth scene next, where with the lip syncing.
Peut-être que c'était un de ces lève-tôt qui font leur bagage le matin, ou même peut-être qu'ils n'avaient pas d'amis.
And that one there is very iconic because it is simply his face and all the facial movements, all that kind of thing. Ralph, you would know very quickly, or at least you would notice even more quickly, that the lips don't match the words, because obviously it was spoken in English, translated to German. This technology was super incredible and really, really, really well done. I think back to Ralph, like actors like, and the first one that came to mind for some reason was Jack Black, who for the movie with the Mexican the Mexican wrestlers. I want to say like luchador or something like that. Nacho Libre. That's what it is. Nacho Libre. He actually taught himself Spanish. Like he actually taught himself Spanish for that role. Actors don't have the luxury of doing that for every single role in every single language out there. Yeah. So
and I think to build on what you were saying, especially with the scene in the courtroom there, is if you notice that, and he's speaking in French, but the lips close and open perfectly with what's being said. And that is a very difficult thing. What I understand, and maybe you've heard this too, Ben, sometimes they have to rewrite scripts for the person who's speaking the language, let's say French. They have to rewrite the scripts to match the movement of the mouth and the facial expressions, right? So it diverts from the original. That's the point that Scott Mann, the producer, was making. I want to be faithful. This technology allows the script to not be manipulated or changed simply because you're trying to make it look realistic with the mouth movements.
Yes.
And so that's very, very cool.
Happens all the time, and it happens especially with like very impactful scenes where clearly they are meant to say one thing, and then very clearly in other languages they say something very different.
Exactly.
And although this doesn't fix the problem of censorship, like my favorite is like Snakes on a Plane, where they change to obviously they can't say what oh my god, why do you want to say Jackson? And anyway, Snakes on a Plane, and he's like, MF, it is what it is. Instead, on cable, they change it to Monday to Friday plane, or, these Monday to Friday snakes. Like, it's close. And like kind of what you're saying, it matches the lips. It does not convey the meaning whatsoever, but it matches the lips at least. This will not fix that, but I get what you're saying. It's still very cool technology. And if it means that more people in more languages get to share the film, and then, hey, Ralph, even for US speakers, obviously this was meant for, kind of German, French, that whole thing. What if Americans soon will be able to see other films and have it be in English instead of, because I don't know about you, Ralph, but I know people, cough, cough, Craig, that won't see movies that are, dubbed or subtitled simply because they're not in English. So,
and it's, I hadn't thought of that. The reverse, the other direction back. Mm-hmm. Wow, this could help open up a whole world of wonderful international films that, frankly, I'm pretty lazy, wouldn't maybe have the tolerance to sit there and look at subtitles or deal with bad translations. Ooh, that's a good point. I like that a lot. That'd
be very fun. See some of the best films not in English. So there you go. Story number 7, story number 8. Ralph, you have an algorithm thing this month, and but I don't blame you. Yeah.
And Mark Mason at KEX Radio, I do the weekly Friday segment with him, a short little 8-minute thing. And it's gotten to the point where we joke with each other. Says, Ralph, we ought to just call this the Artificial Intelligence Weekly Report, because it's just such a dominant thing in our world. But anyway, here's the story. Headline: New MIT, there's MIT again, algorithm helps robots collaborate and work as a team to accomplish complex tasks. Comes from ScienceDaily.com, written by MIT person Daniel Ackerman. This is a really interesting story, and the zinger comes at the end, basically. Okay, so consider this scenario. Wouldn't it be great if search and rescue teams could work collaboratively with a team of ground and or flying drone robots, or a combination of all the above? Researchers at the Massachusetts Institute of Technology decided to fully explore this possibility, but realized from the outset that orchestrating a team of robots, of course, is no simple matter. How do you ensure that a group of robots deployed to help search a complex environment, such as a forest or collapsed building, aren't duplicating each other's efforts? Now, to tackle this challenge, MIT researchers designed what they call an objective function algorithm to determine the value of a proposed task for each individual robot working as part of a team of robots. So again, an objective function algorithm to determine the value of a proposed task for each individual robot working as part of a team of robots. For example, their new ultra-smart algorithm eliminates the chance that a robot might execute a wasteful battery-draining maneuver just to gain a smidgen of information. This is, you have to let this sink in. It's really pretty profound.
And I was just thinking, like, to put that into something, I guess that would kind of make sense to me. It'd be like if your Roomba, if according to the computer, your Roomba missed a 1 centimeter little sliver of the carpet that it did not vacuum, but it, of course, did the other 2 sides of it. I guess this algorithm would weigh, we could go all the way across the room and get that one little sliver of carpet we didn't get, but it would waste a lot of battery, or we can just move on with something, a much larger piece of carpet.
So much like the way we humans would look at that and say,
of course.
We constantly in our minds, without thinking really, are doing trade-offs about, is it really worth the effort for that return? Okay, I'm going to go on. The bigger mission's more important. That's the point. So unlike previous robot team programming, that's the key, robot team programming, which just assigns tasks to robots sequentially or in a linear fashion, the new MIT approach creates a more collaborative effort. So let me illustrate. We are all familiar with those fantastic, I think Intel was behind it.
Drone shows.
Like a Super Bowl or whatever, those drone things and beautiful constellation-like
I believe they're called drone swarms.
Drone swarms, thank you. And doing beautiful patterns and stuff. Well, that's very interesting and very profound, and I'm not belittling it, but it's sequential. It's like drone A will go here at this time, 2 seconds later it'll go there, and then drone B will do that, right? That's what we're talking about with this kind of linear or sequential programming. The new MIT approach with regard to multiple drones or robots takes a more collaborative effort, and this is where it gets really interesting. In fact, the smart robots or drones MIT envisions using their algorithm will be able, as needed, to come up with a robot team plan of action, ding, 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 themselves on the fly in real time. So it's kind of like machine learning, on the fly, AI. It's just like, what? They can figure out that not only are they eliminating wastefulness, if you will, and making judgments about what action is valuable or not, but as a team, they can realize a changed situation. Say it's a fire situation in the forest, and all of a sudden the area they were supposed to be deployed to is now dangerous. It's on fire. And so they can, on the fly, communicate with each other and decide as a team, nope, we're going to go over here now. That part is lost. We're not going to be able to do anything there. I don't know. To me, that just was really something.
Maybe we've been talking about the military too much with, those organic robots and things like that. But my first example would be, imagine tiny little drones and you had a swarm of them and you were able to kind of say, we need to scout out this building. Obviously you don't know the interior, you don't know who's there, what's been put up, what's been done, but you could release a swarm of these drones and they would independently all be able to relay to each other and of course back to humans, and they'd be able to swarm throughout this building and map it out from the inside with video footage and things like that on the fly. The applications are search and rescue, disaster relief, obviously military, and so many other applications. It's really artificial intelligence is really strong and impactful. It's incredible.
Well, and the thing that I love about the inference of this article, if I'm interpreting it correctly, is it's sort of on the fly collaborative machine learning and communication. With a team.
Right. Yeah.
Wow.
It's and that on the fly part is super important because, like you said, you don't always have a big open, FDA cleared space for not FDA, Federal Aviation, FAA cleared space. Yes, there we go. FAA cleared space to maneuver these drones, and being able to do this is super, super important. And of course, Ralph, drones today. Who says maybe not cars tomorrow, and being able to self-drive cars in this manner as well. Not saying cars are going to fly, but you kind of get my meaning. Story number 9. Let's talk about story number 9, and then I think after the story we might have to start picking and choosing, but we'll go story number 9.
So story number 9 is kind of a interesting trends. We've been talking about robotics a lot today, along with AI, of course. Headline: first quarter of this year, 2021, robot sales increased 20% over Q1 2020. Comes from this is a really interesting website, robotics247.com, a story by Eugene Dematri. I hope I'm saying that right. And here we go. The Association for Advancing Automation recently announced that robot orders in the first quarter of 2021 were 19.6% higher than in the same period last year. North American companies purchased 9,098 units, valued at $466 million in Q1. Robot purchases by car makers and their component suppliers combined saw a 12% increase year over year. If they could just get chips to put in the cars. Oh, well, I digress. The announcement also noted that in 2020, orders of robots from non-automotive sectors surpassed automotive robot orders for the first time. That's interesting. And the trend continues. For example, robotics purchased by the life sciences, pharmaceutical, and biomedical sectors increased by 72% over the same period last year, and 32% increase in the food and consumer goods sector. So not a bad time to be in robotics.
Yeah, and obviously, they've been talking about that shit for quite a while now. But yeah, I'm sure that the pandemic has, as you mentioned, really accelerated the the spending in that field. So I was looking through the other stories, Ralph, and honestly, kid at heart and, mostly kid outside. Story number 14. I think everyone has played air guitar. Everyone has mimicked a piano, that kind of thing. And Sony has taken it to the next level.
Yes, this is so interesting. It's not that it's super incredible high tech, but I just thought it was very clever and interesting. This story comes from The Verge, written by Sam Byford. Headline: Sony launches motion sensing music effects controller. And you really need to see and hear the video to get the full impact of this. But here we go. There's a new Sony product for musicians that makes their arm and hand movements create sound effects as they play piano, guitar, you name it, called Motion Sonic. It is, in the words of Sony's campaign, a device that affects gear, meaning keyboards or guitars, to control sound in sync with your motion for playing music. The Motion Sonic device itself is a small capsule that can slot into differently shaped rubber wristbands, and sort of like the rubbery thing that holds my Fitbit on my belt. There's a band, a rubber band, if you will, or a attachment that attaches to your wrist for use cases like playing guitar, and another wraps around the back of your hand and is better suited for playing keyboards. What it actually does is allow you to link hand motions to specific musical effects. For example, you could set it to add a delay effect when you move fingers from left to right, or bend pitch as you roll your wrist. These effects are all created and saved on an Apple smartphone iOS app. And using the app, you connect your iPhone to your instrument with an audio interface. And by the way, this is not available yet for Android. The product is scheduled to ship in March of next year and will sell for $248. So this is really aimed at, I would think, pretty close to your professional musicians or people that compose music for a living, or live music playing DJ like people.
And really the video is very telling that there are some musicians out there that if they had enough arms, they would play all the instruments at once. But this is the next best thing, and be able to control it very, very effectively. Obviously, we have had on not Panasonic. No, it wasn't Panasonic. Oh my God, they make pianos. I am. It might actually
Yamaha?
Yamaha. There we go. We've had Yamaha on, and making these MIDI controllers and making all this equipment to actually reproduce instruments digitally. I mean, they're expensive. They're in the $5,000, $10,000, $15,000 range. It's no joke. And for this thing to be able to at least simulate certain aspects of it. They're not saying that these things are going to fully replace your equipment, but to be able to do certain effects and play certain things and do that kind of thing for just a couple of $100, that is a huge improvement. And the fact that they're using like a Fitbit, that's really, really cool as well. Ralph, I think we have time for story number 12. It's one of the longer stories you have, but as someone who just went through a big home renovation and I had to move a number of fridges, I'm not happy with the amount of fridges I had to move upstairs. Whenever you tilt these things, or whenever you put them on their back or do anything like that, everyone around you goes, "You're killing it! You're killing it!" And it looks like in space that's a bit of a different issue.
Real problem, right?
Story 12.
Yeah, this comes from Purdue University, a news release. Headline, engineers, and I'll blast through this quickly because I know we're running out of time. Engineers are building a refrigerator for astronauts that works in zero gravity and upside down, to your point. Here's the challenge. The canned and dried food that astronauts currently eat during missions has a shelf life today of about 3 years. For long-term missions to the moon or Mars, of course, astronauts really need a refrigerator to support much longer viable food storage. But today's refrigerators can't work in zero gravity or upside down if oriented the way when a spacecraft lands on another planet. A typical refrigerator, like the one you're talking about, yours and mine, gravity helps the compressor to keep liquid and vapor where they're supposed to be. In addition, the oil lubrication system inside of a traditional refrigerator's compressor is gravity-based. So a team of engineers from Purdue University, Whirlpool Corporation, and an outfit called Air Squared Inc. has been working for 2 years to create a refrigerator for zero gravity that operates using an oil-free compressor. The oil-free compressor will allow the refrigerator to work in zero gravity and in different orientations. And with this new invention, the team hopes to provide astronauts with a supply of food that could last up to 5 to 6 years. And does it work? Yes. The team recently conducted a successful test in microgravity simulated in parabolic plane flight. And parabolic plane flight, remember, that's where you train astronauts and other people. You descend so quickly that it replicates zero gravity, okay? That's what they're talking about. And here's an interesting twist. In addition to being installed on space stations, the team hopes their new refrigerator could be sent into space and be set up, for example, on the moon or Mars ahead of a mission. So you could have a payload go to Mars, let's say, and deliver this refrigerator and other things and so forth. And then when the astronauts show up, they can start putting together their little habitat and have this refrigerator ready to go. It's just, I love this story.
Between this and, there was one story that I think you did where they were talking about making concrete on the moon, using kind of the dust and silica that's found on the moon. Yeah. I get this feeling that, like, on the moon and Mars, there's just going to be like these big, houses that you would find here on Earth, just with fridges and, concrete walls and that kind of thing, all ready for astronauts to land and just live in. I'm sure that something like that is the goal, not exactly like a house, but, everything ready to go there for survival. I'm sure it's just around the corner. By the way, looking at the video portion with that parabolic flight, seeing the amount of people that they sent up there, Ralph, it looks like a lot of fun. And I'm not sure you needed 20 people in that plane to test that fridge, but hey, free microgravity trip. No one turned it down. I could definitely see that. So
that would be an experience, wouldn't it?
It definitely would be. So, but Ralph, the music means that we are out of time, and we got to almost every story. Like, we missed like 3 stories.
That, huh?
So we're going to include those in the show notes, computeramerica.com. We'll have those up here in just a moment. And Ralph, thank you so much for joining us once again.
Hey, always a joy, friend.
Yep, and of course, Ralph, I need you to stay cool because it's getting pretty crazy out there. So until next time, everyone, he'll be back second Friday every month here on Compute America. And Ralph, until next time, have a great one.
Hey, same to you.
All right, and everyone else out there, thank you for tuning into Compute America. Thank you for listening on IRN, and until next time, have a great day. Thank you so much. Bye, everyone.